Welcome. This will be a fantastic opportunity for me to show some of the new development, but also it might be an opportunity for you to be maybe even more confused. So I don't know what will happen. Anyway, I have been doing a preparation before we start to look to the COP model. Before we made a MultiRun, and we used this MultiRun to also examine the results, and we look to the performance, and we look also how we could constrain the different data to be in some type of agreement with our observations. And this was a little bit complicated, and it was not so easy. And now I would like to show you how you could do it in a way that is more automatic. And that can be, of course, more convenient. But who knows, it can also be still complicated if you would like to learn about what is actually happening. So what I did after the previous is that I just repeated the previous MultiRun, but I have added some things to it, and I will show you what I have added first by going back and looking to the one we have been looking to together. Oh, sorry, I should not open that. This was by mistake. I should know. There. One of the issues are that I was putting the wrong position for the browser, so that's why I had a mistake. Okay, anyway, before we had a run that was called 11,119 XML, and we could revisit that again just to make a type of review of what we had last time. We had been doing a run with 2,000 runs at that time, and that was reasonable for us. It take around 3 to 4 minutes. But now I have prepared something more, and I will just explain to you what I have done for making this preparation. So the first step was that I made a copy, and then I visited the various options that are in the switches. So we can make this a little bit larger so we just see those. And in the switches we have one group that is called the technical switches. And in that particular group I have a new switch that is called Predefined Ensembles. And that have been off before. But if we put that on, we can select also how many ensembles we would like to create. And I will say 6 will be a nice number. So in a way the output should be 6 acceptable ensembles showing different pieces of the environment we would like to handle. Okay, and after we define that we would like to have 6, we have to tell the model what it should do. And then we have something called parameter table in this group of technical issues. So one table called criteria for ensembles, and have for the moment only one element. I changed that to 12, meaning that I could now specify for all those 12 different criteria for how to make the best estimation of those ensembles. So for instance, we can have 2 criteria for the first ensemble, and then we can have 2 for the next, and 2 for all of those. So we had 6 ensembles, so I could put it up to 6. And then I will quickly explain for you that now there are a number of columns here that gives you the possibility to fill in what you would like to have. And that is the criteria how you would like to constrain the model. So taking this transformation, this is actually something that is, if you don't put anything, you have 0, and then you will get no transformation, meaning that the values are as they are. Other possible transformations are that you are accumulating the values in various ways to get them more adapted to the type of dynamics and the type of summation you would like to look to. You have one called zero adjustment. That means that you try to force the ensembles not to be biased. That means far away from 0. Instead, you force them to be close to 0. You have the performance indicators, and we have been looking to those before when we looked to the previous MultiRun. So they could be any of the selection that we have been using to before. And then we have, of course, the variables. So we have an index for the variables. That index corresponds to the ones we have here, so from 1 to 10. So we can fill in the numbers that we would like to have here in this table. Then we have threshold, or threshold type and value. This is how to regulate the size of the ensemble. We can specify now in numbers how big the ensemble should be that remains. Some people, they would like to have an ensemble big enough to have a chance to look to the statistics and the details inside the ensemble. Some prefer to have a very small ensemble that gives you a sharp and precise value of what you are looking for. Those can be, the type is either in percentage or absolute value, and this can be explained more when we look to the simulation that I've done. What more did I do? I went to the MultiRun, and then we had here the 2 values for dimension 1, and we had 1000 for dimension 2. I simply extended this dimension 2 to be 5000 instead of 1000. So that's what I've been doing when you have not been viewing. And now I just would like to close that, because that was the preparation. And the outcome of that is stored in this simulation 131,120. So instead I will open that by clicking on it, and then we see a completed MultiRun that is now with this 10,000. And those 10,000 has been regulated by, first of all, this parameter table. And in the parameter table we had this criteria for ensembles, and you could see how they have been filled in for me in the beginning. So here we have different variables, and those variables represent location 3 or location 4. They represent either the temperature, the soil moisture, or the groundwater level. We had 2 variables for the soil moisture and for the temperature, so that's why we have 2 lines for those. and we put 50% of reduction of the data we looked to by the first, and then we kept 10 after we have been considering also the second. So that's how it works. And now we simply would like to see how those results looks like. And then I can go to the validation tab that we have been looking to before. And then you could see that the location, the ensemble here, have got a little bit more of information. They have got also a label that I have added. But what's interesting is, of course, that now if I make a plot, and we can make a plot first of the saturation level, we will see something that looks a little bit messy, but it is the 6 different ensembles showing how the criteria have been able to give 6 different outputs of possible dynamics of the saturation level. So some have been made based on looking to temperature, and others have been made looking to the soil moisture. Only 2 of those have been made by looking to the groundwater level. And of course we have some feelings, if we remember this from before, who are the ones that are for the groundwater table. To take all away, because it is a little bit too much, we can visit this sheet evaluation of the statistics, evaluation multi. And before we looked to this and we reduced from the number we had before to the posterior, now you see it is already done. So now we have only 10. And we have in the sheet that is the summary ensemble split, we have also a name, and those names I have just added. So you could see the ID for the location and for the variable that have been used to make this constraint. And then we could order them to be plotted or not. Actually now I would like to look to how we could show only those that have been using the groundwater level, either on location 3 or location 4. So if I do so, take this window, we should do one more thing, of course. We should go to our simulation document and we should ask for a new chart. So I clear this and I make a chart now using this saturation level, and then we see only those for location 3 and location 4. So this was what was estimated for the 2 positions. And now we can also click on this to get the measure data. And you see the green line is the measured for the location 4. It's not perfect, but you know, it's in my view quite acceptable. In most cases it is between the band that indicates the uncertainty. The same can also be said for location 3. Maybe you could say that, of course, the rise of the groundwater here is a little bit delayed compared to what it had in the start. But there are many possible explanations for that we may not have covered in the short period, the only 4 days before we started the simulation. The recession here in the end is also a little bit different. So, of course, we can do something, but we should never expect a perfect performance. But probably I will say that this is acceptable, and we also call this, as you have seen, for the acceptable. So that was the groundwater story, and then we can have a new view looking to the I lost this ensemble. I would like to take instead the story about water content. So I look to the water content for, again, location 3 and location 4. And then we take the sheet for the document, and I visit this validation, and I clear this for the saturation level, and instead we look to the theta. And then we had, first of all, this, we can take 7 centimeter first, and then we have what we have estimated for those. So they are different between the two locations, and they were also different in the measurements. So the measurements comes here, the same horizon, and then it's easy to conclude that the picture is not so easy to evaluate as it was for the groundwater. It shows the dynamics. For instance, the rise of the water content when you have the infiltration events here, they are not too bad, but they looks a little bit different in the dynamics, and especially the difference between the two locations are not the same as they are in the measurements. The measurements are more clearly different in the magnitude. The two simulations are, overlapping, and sometimes showing something that is more or less the same, but sometimes it also gives quite clear differences. So this shows that the work that have been done for tuning the soil moisture was maybe not equal good, but still something that was not too far away in my view. What remains is the temperature, and you may remember that the temperature was not very good, because the temperature we had before were systematically too cold. And now I'm eager to see if something has happened to the temperature. So we mark that, and then we go to the sheet where we have the validation variable. We clear that, and we look to the temperature sensor, and we can start with this location 4. So here it comes. And now it is the difference in location 3 and 4 according to the ensembles. And you could see that location 4 is quite sharp. It's not much of variability. Location 4 is much wider. So obviously they have been constrained to different type of dynamics now, and this is because this was looking to one location for also looking to what was the output for the next. And we could compare this temperature at 30 centimeter depth for the correspondent measured values at 30 centimeter depths. And then you could see that those two are quite similar. They are showing more or less the same temperature, and it is, like before, very much above what we simulate. It was on the same level in the beginning, but it deviates substantially in the end. And the explanation why it is so warm in the measurements and so cold in the model, we have to look for later on. But we have got this result by, taking the opportunity to think before. And now we can of course say that we should not think anymore. We have done our thinking, and the only thing we have to do is to distribute the results if we believe that they are good enough. I would like to show you a little bit more on how we can describe those data also with respect to the sensitivity. Actually, I think we failed in the previous to show the relation between especially the parameters and the performance. So I'm eager to try to do that now instead. So we take away those, and instead we should look to, now when we have been looking to the temperature, we can look to the temperature, and we could look to, for instance, the R square. And then we see now we have a lot of runs, 10,000, and those differs between, from 0.64 up to 0.78, something here. What I would like to do is that I would like to show them in relation now to some of the parameters. And then we could go to the parameters, and then if we find the parameters, we have first of all this initial temperature, and if we would like to see now how it is connected to this performance, we can right click here and we can set this as the first independent, and then this shift, and you see a number of lines showing the results for those different ensembles. And it's not so easy to evaluate it, but you could see that it looks like there are some difference in level, but this level is not connected only to this particular temperature. It is probably related to something else, because it looks like a number of straight lines. So who knows, maybe it is connected to, for instance, the drain level, and then we can again right click and put this as a second independent variable, and then we will get something that looks, in my view, a little bit fancy, because now we show more or less as much as we can show in a type of, two-dimensional that is using those contours to show the third dimension. So the soil initial temperature is on the x-axis, and the drain level is on the y-axis, and then the colors or the performance indicators. So we can see that the good performance indicators, they are in this area of the diagram, and the poor one are up here. So to get the good R square, we should definitely not have the highest temperature or the shallow drain level. We can also see what happens if we instead look to something else. Instead of looking to the R square, that is in a way doubtful, we can look to the mean error. And then it shows in the same how the mean error now depends on the initial temperature and the drain level. So the axes are exactly the same. And you could see that again, all are underestimation from minus 2.2 to minus 4.6. So they are not good, but the best are up in this right corner. So here we have those that shows the best with respect to the mean value, and here we have those that shows the best with respect to explanation of the dynamics. So this can be quite confusing. You know, you can never be happy. You always have to see if you get something good, you get something else less good. So we were not so happy with the temperatures, and I will say that we can maybe look to some of the other variables in a similar way. For instance, if I look to now groundwater level, and we can also look to the mean error of this groundwater level. You see that those shows quite different patterns, and the initial temperature does not have much of impact on this performance for the saturation mean. But the drain level have a very dramatic impact, of course, we can say. So when we have a shallow drain level, then we have also here a mean error that is actually above 0. This is, 0.9, and the best ones we would like to have are something in the blue, because here we have the transition from plus to minus. In the same way, we could say that we may find the best ones in this region with respect to the mean error, but if we should look to the R square, that is good indicator for explanation of the dynamics, we should have as high values as possible. So it is all those red spots down here. But you could also see that it's not so easy that everyone is good, because some of those looks like islands, and between those islands you have a type of deep hollows which you don't want to jump into. And these hollows are actually other parameters that we cannot see at the same time. So in the sensitivity we can also see the complexity, and we can see what type of differences it will have depending on what we are looking to. I will say that it's easy to investigate the model. it's tricky to investigate the nature. But if you just would like to see how different things are connected, this type of sensitivity is easy to do by here looking to the performance indication in relation to the parameters. Of course, we can also go further and not look to those here that are the performance. We can also look to some of the output variables. And as you may imagine, the model have many outputs, and all of those can now be viewed and see to what extent they depends on the parameters. So we have here only the hydrology, but for instance, if we would like to know to what extent we are affecting the we can say something that makes sense and is easy. The total evapotranspiration for the whole period that we should have here. Let's click correctly. Yes, if I click on this, then we will see this total evapotranspiration and how it depends on those parameters. So it's not totally random, but it's more or less. So the total evapotranspiration did not have so much to do with this initial temperature and the drain level. Maybe it has something more to do with, for instance, the hydraulic conductivity. If I go there and then I visit the hydraulic conductivity, right click, I can now select this total conductivity as the new first independent. That's it. Now it's marked red here. And then if I now go to the outputs and I click this again. Now it collapsed. Something happened. We were. Now it's back. I actually tried to make two plots because I make an extra click. But here then you see that it doesn't matter. It's still a type of random pattern, maybe like art, but not much of sensitivity. So we can say that if we had been interested in looking to this total evapotranspiration, we should probably need to have some type of check on that also from measurements. Otherwise it is just the output from the model that we can rely on. So I think this is coming to an end for what can be done by just running the model and for looking to the input output and for playing with different methods for how to imagination what can be done. But I would also say that now we have been mostly focusing on the technology and not so much about the real nature. And if we should do the later, then we have to go back, and I will recommend again looking to the school books, or if you prefer, you could read the theory in the Cook model manual to learn about those type of assumptions and principles that are behind more or less all of those things that we have been looking to now. But I will produce some more just to show you more explanation to some of the important technical details, but this series is mostly intended for looking to getting started, so we will not go too deep into that, but we will show a little bit more, for instance, on how to handle the outputs and how to, for instance, transform the data between different formats, because now we have been taking in the data, but if we would like to export the data to other media and so on, it can be good to look to that as well. Okay, thanks for listening to this. Bye bye.